Let's start. Okay. Good morning, everyone. No, sorry. Good afternoon, everyone. Right. Good afternoon, everyone. Okay. Good afternoon, Samya. Good afternoon, Shreya. Good afternoon, Siddesh, Sneha, Suhas, Malik, Abhiram. Good afternoon. Okay. So I hope last class में हम लोग जो रिवाइज किया वो सबको समझ में आया होगा. Right? Raise your hand. सबको समझ में आया? Yes. सौम्या अब टेस्ट का शेड्यूल चेंज हो जाएगा. ठीक है, अब टेस्ट का शेड्यूल चेंज हो जाएगा बिकॉज तुम लोग मार्च में है ना. नाउ वी कैन एक्सटेंड द डेट्स ऑफ द टेस्ट. ठीक है, राइट. सो आई जस्ट गिव यू द न्यू शेड्यूल. ओके. हाँ, कोलिजन वाला तो करेंगे, कोलिजन वाला करेंगे. ठीक है, नो इश्यूज. बट मोस्टली जो तुम्हें चाहिए वो हम लोग एडवांस क्लास में करेंगे बिकॉज यू माइट नीड oblique collision, right? Eccentricity use करने वाला concepts and all those things. So that won't be discussed in your normal class. ठीक है? Okay. Now I hope all of you remember that we discussed till Newton's first law, Newton's second law, Newton's third law. क्या होता है हम लोगों ने देखा था and we got to know how to draw free body diagram and how to use force equation. Okay, right? तो यहां तक हमको सब कुछ आ गया था, हमने यहां तक कर रखा था. Right? So I guess everyone is clear till this point. Tell me, everyone is clear till this point? Yes, raise your hand. Okay, very good, right? ठीक है, चलो यहाँ तक सबको समझ में आ गया. So when you talk about NCERT, so theory wise I keep on saying कि भाई NCERT हो चाहे तुम्हारा JEE हो, concept, when you talk about concept, उसमें difference नहीं है ज़्यादा. The difference is the type of problem that we solve, yes or no, right? The type of problem that we solve. Okay, for example, 5.1, 5.2, 5.3, you guys can solve, right? Okay, now there's a term called impulse. This is just one concept that we have to know. What is impulse, guys? Impulse का मतलब क्या होता है, right? I guess all of you can say practically what is impulse, right? When you apply force on any object for a very short duration of time, yes or no, right? Yes or no, right? Or I can say, okay, it is change in momentum, because when you talk about this force, okay, and when you talk about time, so I know F is equal to delta P by delta T, right? And impulse by definition, it is the force applied over a very short period of time or over any time period, right? So I can say this impulse is force into time period. Now if you use this, can I say, okay sir, delta P is equal to F into delta T? Yes or no, right? Where this delta T is nothing but time period, or sorry, time duration, and this is your force. So I can say impulse is nothing but change in momentum, as simple as that. ठीक है, और कुछ नहीं है ना? बन जाएगा, इस पे क्वेश्चंस बन जाएंगे, easy. Okay, now Newton's third law. I hope everyone remember the concept of Newton's third law. Third law सबको पता होगा, as a definition, as a theory, what third law says, right? ये मुझे बताने की जरूरत नहीं है. Everyone know what is Newton's third law? To in every action there's an equal opposite reaction. Yes, yes everyone. Okay. Okay, now अभी हम बात करते हैं एनसीईआरटी की. तो हमारा एनसीईआरटी में बस इतना ही है. देन वी टॉक्ड अबाउट कंजर्वेशन मोमेंटम, राइट? हमारा फर्स्ट लॉ, सेकंड लॉ, थर्ड लॉ इतना ही है. आफ्टर दिस वी कैन टॉक अबाउट कंजर्वेशन मोमेंटम. बट अगर तुम किसी भी कॉम्पिटिटिव एग्जामिनेशन के प्रिपेयर कर रहे हो, सो हमारे पास डिफरेंट टाइप ऑफ प्रॉब्लम्स हैं न्यूटन सेकंड लॉ में ही, फ्री बॉडी डायग्राम बनाने में ही. ठीक है, एंड वी हैव सीन सम, राइट? सो लेट्स सी before starting conservation momentum, right? So I can say, okay sir, if we talk about type of problems in Newton's second law itself, ठीक है, हमारे पास क्या है? Different type of forces, different type of free body diagrams, right? And how to solve a problem based on those free body diagrams. सबसे पहला है मेरा पुली वाला, जो सबसे ज्यादा पूछता है, पुली, the concept of pulley, right? है ना? सो आई होप कि सबको पुली आसान लगता होगा, एक पुली दो पुली तो आसान लगता होगा, है ना, राइट? एक या दो पुली आसान लगता होगा, yes or no? If I'm having only one or two pulleys, right, just imagine if I'm having just like this, एक या दो पुली, है ना, राइट? तो ये प्रॉब्लम्स काफी इजी है, हम लोगों ने ऑलरेडी कर रखा है, ठीक है। चलो अब एक से बढ़ाकर मैं दो पुली कर देता हूँ, राइट? नाउ आई इंक्रीज द नंबर ऑफ पुलीज, then what to do? Right? Suppose I'm having something like this. Wait, this one. Something like this. Okay. Okay, अब बताओ. Now, how we will solve this? Tell me, how we will solve this? Everyone, think about it. Everyone, tell me. We have solved this, yes or no? I hope all of you remember. This was the last question that we discussed in the last class. ये हमारा last question था. Yes or no? Right? Where I gave you the analytical approach to find the constraint relationship. Yes or no? Okay? Yes. Now, analytical approach समझ में आता है, but someone of you asked, sir, how to solve it, right? How to solve it equation wise? How to find the acceleration of this and acceleration of this? है ना? Right? So the first step which we studied, step one. Tell me, what was step one? What was step one? Last class में हम लोगों ने कर रखा है इसको. What was step one? Free body diagram. Very good, Samya. Free body diagram, FBD. Right? Very good. What is step two? What is step two? Tell me. Force equation. Force equation, right? Anna? Yes, in respective axis. In respective axis. Axis. So यहाँ पे सिर्फ y axis है, यहाँ पे तो x axis है नहीं, तो यहाँ पे हम ज्यादा वरी नहीं करेंगे, right? Force balance. Yes. Now, after this, what is the third step in this? Tell me, what is step 3 in this kind of problems? Because हमें JEE और नीट में इससे ऊपर का क्वेश्चन नहीं आएगा, जो नॉर्मली इससे ऊपर क्वेश्चन नहीं आएगा, ठीक है, right? Yes, only acting on the body, not on the by the body, right? Step 3 is constraint equation. हाँ या ना, tell me, right? अब तुम लोग का डाउट ये होना चाहिए, ओके सर, आपने पिछले क्लास में कंस्ट्रेंट इक्वेशन एनालिटिकली बता दिया कि सर ये x नीचे जाएगा तो ये ऊपर जाएगा, बट हाउ टू सॉल्व इट, राइट? यूजिंग मेथड, ठीक है, यूजिंग सम डेफिनेट मेथड. लेट्स सी. सो वी नो, एक चीज बताओ, ये जो लेंथ ऑफ द वायर है, टेल मी, लेंथ ऑफ दिस रोप इज कांस्टेंट, यस और नो? हाँ या ना? लेंथ ऑफ द रोप इज कांस्टेंट, एग्री? यस, सबको पता है? Suppose the length of this rope is L. Suppose the length of the rope is L. ठीक है? Yes. Okay. Now I can say yes. Inelastic है. This distance is suppose x1. This is your x1, right? This distance x1. यहाँ से यहाँ ये distance को मैं मानता हूँ x2, और this whole distance, ये वाला distance is x3. Suppose. ठीक है? Suppose. Right? Or instead of x3, instead of this x3, I'll just write this. Or you can write x3, doesn't matter. Write x3. ठीक है? Okay. Or you just wait. Write this general position. ये मान लो this position is x1, this is x2, and this is x3. x3. ठीक है. So what is the length of the rope, guys? What is the length of the rope in terms of x1, x2, x3? Tell me. And don't you think, sir, x2 and x3 should be same, na? Sir, x2, x2 should be same, right? x2, x3 sir same होगा. क्या दिक्कत है इसमें, right? x2, x3 should be same, na? Yes or no? Because ये भी इस पुली का लेंथ है और ये भी इस पुली का लेंथ है, right? है ना? Right? x2, x3 is same actually. x2, x3 is same. ठीक है ना? साम्या, got it? Right? x2, x3 is same length of this pulley, this distance, right? So if you want to write the length of this rope, बताओ length of the rope कौन होगा, क्या होगा? Step by step. Sir, length of the rope ये होगा, ये distance होगा, ये distance होगा और ये distance होगा, right? ठीक है. तो सर ये जो blue वाला distance है, सर ये जो blue वाला distance है वो क्या है? और ये this is x2, this is x2. सर ये जो blue वाला ये distance है, this distance, this is x2 minus x1. Wait. Or just consider this distance as x1, right? ये पुली को और ध्यान दो. Consider this pulley. ये actually मैंने यहाँ पे distance मान लिया है, but actually में जब हम लोग लेते हैं ना तो हम लोग almost इसको मानते हैं कि ये roof में touch किया हुआ है, ठीक है? Almost मानते roof में touch किया हुआ है. समझ में आ रहा है? Right? So forget about this. Assume that this is touching the roof. Okay. एक मैं diagram थोड़ा सा गलत बनाया है. Diagram थोड़ा सा गंदा है. ठीक है. Assume that this is touching the roof. ठीक है. Assume that this is touching the roof. So I can say the total distance is x1. Wait guys, something happened to my writing pad. Okay. Okay, it is x1 plus 2x2. Yes or no? This is x1, this is x2 plus x2, 2x2. It is the length of the rope. हाँ या ना? समझो. ये generally touch करता है यहाँ पे. This is generally touching this, right? So this is total x1. So x1 plus 2x2 is equal to L. Yes or no? हाँ या ना? बताओ, yes or no? I'll just draw a better diagram. Wait guys, ये तुम लोग थोड़ा सा confusing लग रहा है because diagram मैंने clear नहीं बनाया है. ठीक है. Just give me a minute. I'll just draw a better diagram, right? मैं थोड़ा सा अच्छा diagram आता हूँ. So this is like this. ये actually पुली ऐसा है, ठीक है? और ये मास ऐसे है. This is like this, and this is the pulley like this, and this is like this. ठीक है. So ये distance, ये और ये अब समझ में आओगा, अब क्लियर हो गई है ना? So this is the equal length. ये दोनों almost equal है और ये x1 है, and this is your x2. This is x2. So this is also x2. Length of the rope. So length of the rope is x1 plus 2x2 is equal to length of the rope. इसमें किसी दिक्कत है? Tell me, हाँ या ना? इसमें किसी दिक्कत है? Guys, right? तो अगर x1 चेंज करेगा, think about it. अगर x1 चेंज करेगा means m1 मूव करेगा, हाँ या ना? If x1 is changing, which means m1 is moving, and if x2 is changing, which means m2 will move. Yes or no? Yes or no? Right? So can I say, okay, so इसको double differentiate कर देता हूँ मैं. So d square x1 by dt square plus 2d square x2 by dt square is equal to 0, because sir constant का differentiation तो 0 होता है ना सर? हाँ या ना? ये स्टेप समझ में आया कि नहीं? ये स्टेप, this step, x1 plus 2x2 is equal to constant, differentiated twice, not once, twice. दो बार differentiate कर दो इसको, है ना? So x1 का दो बार differentiation करने के बाद क्या आएगा? d square x1, right? And x2 का differentiation 2x2 differentiation करने के बाद क्या आएगा? Tell me, d square x2 दो बार, yes or no? Clear? Everyone is clear with this? And what is d square x1, guys? What is d square x1? Don't you think, sir, this is the a1 plus what is this? 2a2 is equal to 0. Yes or no? So a1 is equal to minus 2a2. साम्या, मुझे acceleration चाहिए ना साम्या? What is the definition of acceleration? Double displacement of position is, sorry, double differentiation of position is your acceleration, na? Right, Samya? है कि नहीं? समझ में आ गया तुमको? नहीं है पूछो, नहीं है पूछो, ठीक है। तो अब ये देखो, ये डायरेक्टली आ गया, a1 इज इक्वल टू माइनस टू a2, मेक सेंस, ये नीचे आएगा तो ये ऊपर आएगा, दैट्स व्हाई माइनस। अब ये मेथड है, दिस इज द मेथड, राइट? एनालिटिकली नहीं सोचा हमने कि सर ये रस्सी x खुल रहा है तो ये रस्सी x by 2 पर खुल रहा है, एंड ऑल दोस थिंग्स। क्लियर है? टेल मी नाउ, दिस इज क्लियर एवरीवन? सिद्धेश, समझ में आया ये? स्नेहा, तुलिका, श्रेया, प्रियंका, अनीशा, Priyanka is not here. Suhas, Nishita, Riya, everyone is getting this? Tell me. Right? So this is the method. Easy है लग रहा है? सबको सही लग रहा है? Easy लग रहा है? Yes, exactly. It will always be true until the length is constant. Length will be constant. ठीक है? So अब बताओ, अगर तुमको 2 की जगह 3 पुली दे दिया जाए, 4 पुली दे दिया जाए, so you can find ना, you can find the relationship between A1, A2, A3, right? ठीक है, बट हमें जनरली 2 पुली दिया जाएगा। नॉर्मली नीट में, जेई नॉर्मल लेवल में 2 पुली दिया जाएगा, 3 पुली दे सकता है, बट you can find using length method, right? Clear? Everyone is clear in this? Everyone is clear in this concept? Okay, very good. So length method सबको समझ में आ गया? Easy लगा, है ना? बस length of the rope should be constant. That's the only thing that you have to consider. Okay. Now, wait, let me show you some problems. Just give me a minute. Okay, yes. So देखो, ये प्रॉब्लम्स हम लोग सॉल्व कर रहे थे। आई होप ऑल ऑफ यू रिमेंबर वी सॉल्व दिस प्रॉब्लम, और ये मैंने अभी एक्सप्लेन भी किया है ना, लेंथ मेथड से। क्लियर हो गया ये चीज? ओके ओके। नाउ कैन यू सॉल्व दिस प्रॉब्लम गाइस? ये एक वार्म अप प्रॉब्लम, एक वार्म अप प्रॉब्लम ट्राई करो, सॉल्व करो इसको। ऑलमोस्ट सिमिलर प्रॉब्लम, ऑलमोस्ट सिमिलर प्रॉब्लम, हम लोग स्टेप बाय स्टेप सॉल्व करेंगे, ठीक है? If you did this, है ना, so mg sin theta is equal to t, and this t is equal to this second mg. So we'll just write the force equation on this, both mass A and mass B, है ना? So यहाँ पे इसका इक्वेशन क्या होगा? mg sin theta is equal to t, right? This is m1, और यहाँ पे क्या होगा? This t is equal to mg, अगर इक्विलिब्रियम में है तो, if it is in equilibrium. Now it is given that what would be the masses so that it will be in equilibrium, right? So equate कर दूंगा मैं, आ जाएगा, this is the answer. Okay, yes, capital M is equal to m sin theta. Very good, very good. Now अब ये क्वेश्चन ट्राई करो, ये क्वेश्चन। Now this is the good one, right? This is comparatively good one. Very good, Smith. Question number, this example, try solving this example, everyone. Guys, I hope all of you are trying. I'll just help you guys, okay? Now, free body diagram. सबसे पहला काम, free body diagram, as simple as that. Right? Okay, Meet, right? ठीक है, चलो पहले देखते हैं। अगर मुझे सॉल्यूशन नहीं पता, अगर मैंने फर्स्ट स्टेप नहीं देखा, तब दिक्कत होता है मुझे। What to do, right? That's the issue, right? एग्जाम में सबसे पहला इशू क्या होता है? सर अप्रोच कैसे करें, है ना? So again, every problem is just follow this algorithm, right? Sir, हमें पहले निकालना है क्या? फ्री बॉडी डायग्राम पहले बनाना है। So mass क्या है? This is the mass. This whole, right, weighing machine, suppose, right, this whole setup is your mass 1, ठीक है? So I can say, okay sir, if I take mass 1, so I can find the free body diagram on this, ये टेंशन ऊपर, ये टेंशन ऊपर। सबको दिख रहा है ना? I hope everyone is getting this. Everyone is getting this, right? Because this pulley, so this tension is actually pulling it up, right? These two wires on this pulley is pulling it up, and the tension will add up. So I'm having one force which is 2t in upward direction? Yes or no? Step by step, free body diagram, step by step. Okay. Now, second, this man is standing on this, right? This man is actually standing on this platform. So the mass mg will be in downward direction. Yes or no? Okay. Right. And one more thing, this is the mass, overall mass. ये इसका नहीं, ये overall mass पूरे system का mass है. Now if this guy is pulling, imagine को यहाँ पे थोड़ा सा तुमको imagine करना है. तुम खुद सोचो एक बार. Just be in this situation, right? If you are trying to pull yourself, तुम force कहाँ लाओगे? नीचे की ओर लगाओगे, नहीं लाओगे? Just imagine if you're trying to pull this by yourself, you will apply force on this weight, yes or no? सबको ये imagine हो रहा है? Everyone is imagining this. Everyone is getting to understand this, right? Everyone is understanding this, right? So I can say, okay sir, इस object, sorry, इस body के कारण जो platform पे एक नीचे की ओर normal force भी लग रहा है. Yes or no? Right? Yes or no? Okay, so this is just the free body diagram of this whole setup, right? है ना? Clear है? Tell me, yes or no? Yes or no? ये सबको समझ में आया? ये सबको समझ में आया कि नहीं कि सर ये नॉर्मल कैसे लग रहा है? That's the concept. Because after knowing this concept, finding the finding the equation is easy. Okay, so I can say, okay sir, this is the FBD of overall setup. हाँ या ना? Tell me, yes or no? Everyone understood this concept? Yes or no? हाँ या ना? किसी को दिक्कत है इसमें? सबको समझ में आ रहा है ये चीज कि क्या हो रहा है? मान लो कि अगर ये बंदा, just imagine if this guy, right, would have his leg up in the air, then अगर मान लो ये वायर, ये जो वायर पकड़ के लटक जाए, है ना, लटक जाए, right, so that he is not standing on this platform, then no normal. Clear है? ये सबको समझ में आना चाहिए. Okay, ठीक है, चलो. Because HCV में भी एक ऐसा सवाल है. Now, ये तो हो गया टोटल सेटअप. अब तुम बात करो मैन की, अब इस इंसान की बात करते हैं. What are the forces acting on this, right? What are the forces acting on this? Tell me, sir. इसके कारण, अब इसके कारण एक mg नीचे क्यों लग रहा है, right? ये जो वायर इसका टेंशन ऊपर क्यों लग रहा है? Now, according to Newton's third law, if this guy is applying normal on this surface, then the surface is applying normal on this guy, right? Yes, T mg normal. Very good, Samya. Very good. So I can say on this man we have mg, tension and normal. Clear है? सबको समझ में आई ये चीज? हाँ या ना? Step by step. Yes or no? Anyone have any doubt till this point? तो अगर फ्री बॉडी डायग्राम आ गया, अगर फ्री डायग्राम बन गया तो हमें तो इक्वेशन बस लिखना है. सो नेट, if it is in equilibrium, in the problem it is said that it is in equilibrium, right? है ना? So for equilibrium I can find the equation, yes or no, because in y-axis, x-axis there is no motion, x-axis there is no force. So along y-axis the sum of all the forces should be equal to 0. So 500 plus n is equal to 2n. That's first equation. Now since the wire is same, the tension is same, so tension plus normal is equal to 700. Tension plus normal is equal to 700. Now I hope all of you can solve because it is a linear equation to variable. हाँ या ना? Right? And what will this weighing machine read? Tell me, what will this weighing machine read? That this weighing machine will read normal force only ना, है कि नहीं? हम लोग जितना फोर्स लगाते हैं weighing machine पे, right, वही मेजर करेगा. Agree? So after solving these two equations I can find the weight, है कि नहीं, measured by the weighing machine. Clear everyone? Everyone is clear on this? बताओ. देखने में लग रहा होगा कि मुश्किल है, but after understanding the concept, right, don't you think that this is not that difficult? बस थोड़ा सा concept इसका था, ये वाला concept, normal वाला concept, that's it. Okay. Okay. Now, I'm not asking you to solve every problem. I'm just asking you to see the, or to go through the type of problems. Okay, you don't have to solve, just go through this. Just go through this. You don't have to solve, you don't have that much time. Okay? Now, can you solve this kind of problems? Now, obviously, समझ तब तो question ही लगा था. If man would have been normal elevator, then the question will be totally different, right? Now, I guess all of you can solve this, right? In this case, we will have tension. The component of tension will be this component will balance mg, normal up direction, right? And this component will balance kx. Okay? So I guess all of you can solve. ये solve हो जाएगा. Okay? देख लो एक बार, step by step देख लो. Because once you know how to write the free body diagram, you can solve all the kind of basic problems, right? जहाँ पे simple free body diagram बनाकर force equation लिख के मेरा question बन जाएगा, है ना? ये भी बन जाएगा मेरे से, ठीक है? Okay. ना ये सब तो सब basic हो गया. अब हम बात करें accelerated bodies की, right? अब हम बात करें accelerated bodies की. Now we know if a body is accelerated, right, which means the net sum of all the forces should be equal to ma. अभी तक हम लोग इक्विलिब्रियम की बात कर रहे थे. यस और नो? यस और नो? राइट. सो एक बहुत बेसिक प्रॉब्लम सॉल्व करते हैं, बहुत बेसिक, राइट? चलो ये सॉल्व करो, बहुत बेसिक प्रॉब्लम. वेरी गुड. सामने एक बार चेक कर लो, सामने एक बार फिर से चेक कर लो, राइट? एवरीवन प्लीज ट्राई टू सॉल्व. सामने चेक करो एक बार आंसर तुम्हारा. हाँ, अब सही है. नाउ इट्स करेक्ट. Everyone should be able to solve these kind of very basic problems. So I guess everyone can solve this. Hi Anna, tell me, right? Instead of making summation of fx equal to 0, you will just make it as max. Now I can say sir इन दोनों को as a system मान लेंगे, है ना? Right? इन दोनों को as a system मान लेंगे. Very good Nishita. Okay, that also we can solve. In that way also we can solve, right? Agree? Okay. Yes, 2 meter per second square. 2 meter per second square, Nishita. है ना? सबको समझ में आया ये? Tell me, सबको समझ में आया? Yes or no? Siddesh, tell me. Because what we did the same thing. A पे हम लोग free body diagram बनाएंगे. So if you draw the free body diagram on A, right? So I can say, sir, A पे दो contact surfaces, this and this, right? So if we have two contact surfaces, we'll have two normal. Okay, one normal is this, one normal is this. So we don't have anything to do with this, right? Vertical force, because sir vertical में तो move कर नहीं रहा है, तो हमें इससे मतलब ही नहीं है, right? मतलब ही नहीं है ना? This is just equal to 10 Newton. Doesn't matter. We have to worry about this. ये हमारा step by step method है. But if I have to solve it, right? If I have to solve it, think about it. Don't you think, sir, जितना A move करेगा उतना ही B move करेगा? Yes or no? Tell me. जितना A move करेगा उतना ही B move करेगा? Right? Basic sense है ना? ऐसा थोड़ी ना होगा कि A ज्यादा move कर जाएगा, B कम move करेगा. Right? It's not like that. So I can say, okay, sir, I can consider this spool as a system, because when you talk about this normal and this, it is internal force. So I can take this whole A and B as a system, right? And this force 6 Newton is applied on the overall system. Easy. The mass of the system is 1 plus 2, 3 kg, 3 kg. So I can say F net is equal to M total, M system into acceleration, right? So nikal jayega 6 by 3 is 2 meter per second square. Yes or no? Easy. I hope all of you understood. Because the normal, this normal and this normal will be cancelled. It is your internal force, right? Sorry, I was writing and it was paused, I guess, right? My bad. So I was just saying that when you talk about this 2 A and B, since the internal forces, which is normal, are getting cancelled, yes or no? Because they're the same surface, Anna, right? Agree. Now, if they're getting cancelled, I can say, I can consider this 2 A and B as overall system. एक ही system मानेंगे, एक block मानेंगे, जिसका mass 3 kg है, force 6 Newton लगा है, तो acceleration आ जाएगा 6 by 3, which is 2 meter per second square. Okay, now this question is also similar, right? This question is also similar, same concept है, कोई दिक्कत नहीं इसमें. The internal force here is which one? Tell me. यहाँ पे internal force कौन सा है? पहले केस में internal force was normal. In this case, what is the internal force? Tension. Very good. Very good. Right? So I can say, okay, sir, यहाँ पे same concept use होगा, बस यहाँ पे tension आ गया है. Tension आ गया. This tension is this direction. This tension is this direction. Right? So in this case also, I can consider this as one system because internal forces are getting cancelled. Agree? Agree, guys? Got it? Okay. So see, right, how I can say, so A is equal to F by M1 plus M2 because internal forces are getting cancelled. So this is kind of shortcut. Okay. Now, this one. Can I do the same thing over here? Hi, Anna. Can I do the same thing over here? Yes. But यहाँ पे ये F ना देकर टेंशन दे दिया है. F ना देकर टेंशन दे दिया है. Right? So you have to find the tension. You have to write the equation, find the tension. Okay. Try to solve it, guys. Try to solve it. Right? एक solve करो. ये एक problem solve कर दो. Step by step. Step by step. Step by step. Okay. Right? Okay, I'll imagine, right? Samarth, that is the concept. That's why I asked you to solve this. Suppose tension same है. Suppose tension same है. So C, when you talk about mass C को move कौन करवा रहा है? ये tension ही move करवा रहा है ना? Yes or no? If you draw the free body diagram of mass C, you will get T is equal to MA. हाँ या ना? Yes or no? Right? Agree? Agree? इसमें कोई दिक्कत नहीं है? Okay. Now, when you talk about this log B, so I can say on this log B, right? I'll just say it as T1 and T2 by the way. This is T2. On block B, I can say, sir, T1 minus T2 is equal to MB into A. और अगर तुम total system मान लो इसको, तो T1 because T2 is M1A is equal to what? MC, right? MB plus MC into A. सबको समझ में सामने समझ में आ रहा है? ये कॉन्सेप्ट था जो जनरली लोग गलत करते हैं. समझ में आ रहा है सामने तुमको अब? Now tell me, is T1 and T2 equal? Tell me, is T1 and T2 equal? Because acceleration तो same रहेगा. Now if acceleration is same but mass is different, can tension be same? Think about it, everyone. Think about it. If mass is different and expression is same, can tension be same? Hi, Anna. Tell me, everyone. Soumya, Shriyari, Anamika, Siddesh. Very good, Riya. Right? No, na, Mansi, Shilika, Pradyuman. So, समझ में आया? T1 is not equal to T2, right? This is the concept. Sir, रस्सी same नहीं है, sir. Rassi is not same. And आप that tension is same, right? When it is same rope. It is not same. Yes or no? So tension is not going to be same in both the wires. ठीक है? Clear हो गया ये concept? हाँ या ना? Clear हो गया concept? Everyone is getting this concept? Samya, you got it? Sneha, Sai Smriti is here. Mansi, Krishna, Priyanka, you are getting this concept, Priyanka? Right? So expression है ना? अब यहाँ पे देखो, यहाँ पे क्वेश्चन में दिया हुआ है सर, right? The tension in the string connecting block A and B. T1 is given as 8 Newton. Sir, T1 का value दिया हुआ है sir. T1 is given, right? T1 is given, which is this MC plus MB. Mass कितना है? सबका 2-2 kg mass है. So it is 4 into A. So acceleration is given. Sir, acceleration is equal to what? T by 4, 8 by 4, which is 2. 2 meter per second, right? Per second square. Acceleration 2 meter per second square आ गया. So acceleration 2 meter per second square आ गया. So can you find force? हाँ या ना? Force is equal to 2 into total mass. Total mass is 6. Clear है? सबको clear है ये चीज? Step by step देखो, सबको clear है ये चीज? Okay? So I guess this is clear. ये concept समझ में आ गया? This is the concept, right? If the wire or thread is not same, the tension will not be same. Anyone have any doubt in this concept, guys? Tell me, anyone have any doubt in this concept? है ना? So ये general concept है जो generally लोग गलत कर देते हैं. Okay. Now, I guess this is enough for your school. इतने इससे ज़्यादा concept problems आएंगे नहीं, ठीक है? तुम लोग ऐसे questions बना लोगे. एक पुली वाला सवाल कर लेते हैं, एक अच्छा पुली वाला सवाल कर लेते हैं. Okay, so we have already discussed this. हम लोगों ने already discuss कर रखा है ना? I hope all of you remember we have already discussed this expression of A and expression of B. How to find what's the relationship? Okay. Now, इस concept पे एक last सवाल करें, but that would be good. वो है ही नहीं क्या constraint? Very good then, no issues. ठीक है, खत्म हो गया फिर तो, right? Okay, then it is done. The next concept is friction. I hope all of you remember, guys, frictional concepts. Yes or no? Yes or no? Okay. Now, can you solve this? Very basic problem based on friction. ठीक है. Tell me guys, anyone? Death wall in circus, right? Or not in real, but in TV, on TV and all those, like anywhere, YouTube, कहीं भी देखा है डेथ वॉल जहाँ पे लोग बाइक, मौत का कुआं, एग्जैक्टली मौत का कुआं हिंदी में, किसने देखा है? ठीक है, गूगल किए थे वो वैसे, right? So this moth ka kuan, normally what people do, right? They ride a motorcycle on this circular track, that too vertically, है ना? CID में चलो CID से कुछ फायदा तो हुआ. Now my question is, okay sir, if I'm talking about physics, right? So how can this guy either run motorcycle or basically run on the circular track? How? Because mg should act downward. Yes or no? Mg should act downward. ये तो गिर जाना चाहिए, but ये गिर क्यों नहीं रहा है? Tell me. This is the problem. Okay, this is a very basic and very famous problem. I hope all of you remember this. Or the question should be, yeah, how fast he should travel, how fast he should drive so that he should not fall. Tell me. Think about it, everyone. Everyone should think about it. कितना फास्ट ये घूमेगा कि वो गिरे नहीं? टेल मी, कितना फास्ट? तो सबसे पहले तुमको उसका फ्री बॉडी डायग्राम बनाना है, हमेशा free body diagram. That's the concept, right? And in this case, the wall of the cylinder, right? This wall is not frictionless. अगर frictionless होगा, right? या कम friction होगा, is it possible to drive? Tell me. Possible होगा भी? No, it's not possible, right? So I can say यहाँ पे friction का कोई rule है ना? Now tell me, what is the concept? What is the formula? How to solve it? Tell me. सोचो एक बार सबको, क्या होता होगा? स्टेप बाय स्टेप सोचो एक बार, सब कुछ सोचो एक बार, राइट? ये मौत का कुआं है, ये बाइक से रोटेट कर रहा है. सो एट एनी पॉइंट, सपोज एट दिस पॉइंट, राइट? ओके, व्हाट आर द फोर्सेस एक्टिंग? व्हाट आर द फोर्सेस एक्टिंग ऑन दिस बाइक? सपोज ये बाइक है तुम्हारा, इस पे कौन कौन से फोर्स एक्ट कर रहे होंगे? टेल मी. सोचो एक बार. फ्रिक्शन इज देयर. सेंट्रीफ्यूगल, नॉट सेंट्रीपिटल, सेंट्रीफ्यूगल. आउटवर्ड है ना सेंट्रीफ्यूगल, ओके? और mg normal friction centrifugal. Yes, Samya, correct. Very good, very good. Right? So I can say, okay sir, when you talk about this, ठीक है, right? I can say that, yes Malik, very good Malik, very good Malik. So I can say, okay, on this mg is downward. Now this because of circular motion, there's force, centrifugal force, which is in this direction, है ना? Which is in this direction. Now think about it. The next concept है friction किधर लगेगा? अब एक चीज बताओ, normally what is the tendency? इसका tendency क्या होगी? नीचे गिरने की होगी? Yes or no? The tendency of this guy, right, is to fall. mg can't fall करना चाहिए because there is no vertical force, right? So because of this, there should be a friction in opposite direction. But next सवाल, सर friction तो normal कहने लगता है, friction तो normal कहने लगता है. So where is normal? अब obviously when this guy is riding on the wall, right, the force applied by this guy on the wall is m omega square r, and the same force is applied on this using Newton's third law. So I can say sir normal to m omega square r ही हो जाएगा, right? है ना? Newton's third law के हिसाब से. So friction force will be equal to mu n, and if it is not falling, means this rider is in equilibrium. So I can say this friction force should be equal to mg. हाँ या ना? Yes or no? Right? So equate it. I hope all of you can find it, right? Or which is mv squared by r is equal to mu, mv square by r is equal to mg. So mm cut gaya, so it will be what? Solve. V square is equal to gr by mu. So v is equal to root gr by mu. Yes or no? Everyone got this? Everyone got this? Agree? सबका आ गया ये? Sorry, g by mu r. G by mu r, right? My bad. I did some calculation. ठीक है. Okay, ओमेगा निकालना सही है, सही है. I calculated v, right? I calculated v. ठीक है, सही है. ओमेगा सही है, ओमेगा सही है. I calculated v. मैंने v निकाला है. Okay, sorry, I was not audible, right? Am I audible now? Guys, am I audible now? Okay, sorry, I was disconnected, I guess. That's why I was not audible. Yeah, so I was asking this. How many of you have seen bike race? Bike race कितने लोगों ने देखा है? हाथ उठा लो. Right? Bike race. है ना? Cycle race तुम लोग करते होगे, bicycle race करते होगे. Now, what do you think? What happens when you take turn? अगर मान लो तुम साइकिल नहीं चला रहे हो, बहुत स्पीड में साइकिल चला रहे हो, तुम टर्न ले रहे हो, या बाइक कोई चला रहे हो बहुत, या मोटर जीपी और एनीथिंग, राइट? अगर तुम टर्न लेते हो, if you're turning, what happens? Tell me. Slant, right? Very good. Very good, Samya. I hope this is something that everyone have observed, है ना? सबने at least ये observe किया होगा that whenever we take turn, right, we slant. Yes or no? Bike slant करता है. Okay. Okay, so how many of you see, how many of you remember some movie scenes where when you talk about high speed chase, right? The car skid. Tell me, skidding of car or skidding of bike. Right? Why that happens? Tell me, वो क्यों होता है? Why that skidding happens? Chulika, Samya? हाँ, वो तो YouTube में दिख जाएगा. मानसी, प्रियंका, श्रेया, प्रद्युमन, निशिता, निधि. Tell me, Jasharan. Very good, Siddharth. Yes, it is due to centrifugal force. है ना? Centrifugal force. Now, so I can say, okay, sir, if I'm having a slant road, right? Sorry, not slant road. If I'm having your normal road, which is not slanted, okay, and if you're turning, just think about it. If you're turning like this, then your motion will be curvilinear, right? Your motion will be curvilinear. And whenever we have curvilinear motion, we will experience a centrifugal force in outward direction. Yes or no? Yes or no? Right? And usually if friction is not enough, then because of this centrifugal force, we slide. Okay, right? I hope all of you understood the concept. Okay, now when you talk about bike or your cycle, you can slant, right? You can slant such that you can have two components of your mg, you can just reduce the component of mg, reduce the normal force by slanting, right? है ना? But what about cars? What about cars? Cars cannot slant, na? Cars, they cannot slant, right? Okay, so in order to prevent this drifting, okay, in cars, usually road are banked, means they are at some angle. Whenever there's a turn, right? Whenever there's a turn, okay, the roads are banked, means ऐसे height होगा, यहाँ पे height होगा, एक certain angle से उठा रहेगा road. Have you noticed this? I'm not talking about normal road, I'm talking about normal जहाँ पे बहुत right speed से चलता है वहाँ पे, especially your race tracks, right? So if you observe race track, अभी तुमने MotoGP देखोगे या F1 देखोगे ना, right? So road थोड़े से slanted होते हैं. Yes? Okay, now why is it so? Why is it so? Because cars cannot slant, right? है ना? Cars तो slant नहीं हो सकते हैं. So the slanting is done, okay, the slanting is done to minimize or to increase the friction force, है ना? To prevent drifting. And how it is done? Now let's see. Suppose I'm having the slanted road, right? Observe करो, ठीक है, क्योंकि ये NCERT में है. Banking is in NCERT and derivation might be asked. Now, if you draw the free body diagram, think about it. If you draw the free body diagram, normally ऊपर की ओर एक normal है, नीचे की ओर एक mg है. That's it, right? Or this is the direction of friction because it will have tendency to fall. Okay, right? What else? Tell me what else? What else? Don't you think, sir, अगर ये rotate कर रहा है circular path में, this is just one point, right? If it is rotating a circular path like this, there will be outward force, which is mv square by r. हाँ या ना? Tell me, yes or no? There is one additional force, which is mv square by r. Agree? Tell me, agree? Now, suppose if friction is not taken, अगर हम लोग friction नहीं ले रहे हैं, suppose अगर friction नहीं है, if there is no friction, right? And if there is no banking, अगर ये banking नहीं होता, slant रहता, then obviously the car will drift because there is no force to balance this mv square by r. Yes or no? हाँ या ना? If there is no banking, if there is no friction, then there is no force which will balance this, right? Agree? Okay. Now suppose it is banked, so I can say, okay sir, यहाँ पे मेरे पास एक component है normal का, ये component है which is n sin theta, और ये component n cos theta. So I can say even if friction is not considered, I can say sir n cos theta क्या हो गया? N cos theta is mg और n sin theta is this force which is mv square by r, है ना? तो यहाँ से मुझे थीटा निकल जाएगा. Tell me everyone. This is the case when it is not sliding neither upward direction nor downward direction, because we know the friction comes into play when there is tendency to move, right? Agree? Okay, so यहाँ पे हम बात कर रहे हैं, if I'm not considering friction, then n sin theta is mv square by r, n cos theta is mg, so tan theta is this. So v is equal to root rg tan theta. So this is the velocity, okay, maximum velocity which a car can have without drifting. ठीक है? सबको समझ में आई है? हाँ या ना? सबको समझ में आई है? Here I didn't consider friction. I'll consider friction, उसका अलग ही question आएगा, but this is without friction. ठीक है? ये NCERT में भी है. This is in NCERT also. So I guess ये concept सबको समझ में आ गया होगा. This concept is clear. Okay, right? Okay, right? Okay. So this is it in NLM, right? Normally NCERT सबसे इतना ही है. आगे कंजर्वेशन मोमेंटम है, so it will take time. हम लोग का उसमें ज्यादा टाइम लगेगा. So कैन आई टेक वन एक्स्ट्रा क्लास समडे, लाइक कभी भी होगा तो? Anyways, maths class I'll be taking, no issues, right? Maths class I'll be taking physics only. Okay. Try solving this problem before concluding the class. Try solving this problem. ठीक है, ये problem try करो. This try this problem. यहाँ पे friction laid है. Okay, so we have to do the same thing, but you have to consider friction here. Okay, so try solving this, guys. Try solving this. Okay, अभिराम. विदाउट फ्रिक्शन का कॉन्सेप्ट सबको समझ में आ गया? निधि, निशिता, अनीशा, चुलिका, सिद्धार्थ, सौम्या, खुशी, खुशी, एवरीवन. विदाउट फ्रिक्शन का कॉन्सेप्ट समझ आ गया ना? सो चलो मैं विद फ्रिक्शन बता दे रहा हूँ. The only difference, right? The only difference that we have here is friction. That's it, है ना? So हम लोग जब free body diagram बना रहे थे, तो friction can act in both direction depending on कि sliding tendency किधर है. Yes or no? हाँ या ना? Tell me. Right? Think about it. अगर V जो है, as I told you that sir, V is equal to root. Tell me, V is equal to root RG tan theta, है ना? ये हम लोगों ने किया. अगर सर V इससे ज्यादा है तो टेंडेंसी ऊपर जाने की होगी, ऊपर स्किड करने की होगी. यस और नो? और वेलोसिटी इससे कम है तो टेंडेंसी नीचे स्किड करने की होगी, नीचे जाने की होगी. एग्री? एवरीवन अंडरस्टूड दिस कॉन्सेप्ट? आई गेस ये सबको समझ में आया होगा, बिकॉज दिस इज एट इक्विलिब्रियम. अगर वेलोसिटी इससे ज्यादा है तो ये कार ऊपर जाना चाहेगा, और वेलोसिटी इससे कम है तो कार नीचे आ जाएगा बिकॉज ऑफ mg. And depending on that, the direction of friction is decided. ठीक है, चलो तो यहाँ पे part by part में explain कर रहा हूँ, part by part. So A, what should be the banking angle so that the car traveling at speed v needs no friction? तो हम लोगों ने already कर रखा है sir. This is the answer. We did it, right? तो ये आता है, A हो गया हमारा. B, the coefficient of friction between the tires and the road is given. Okay, अब friction है. So this is a static friction and this is a kinetic friction. At what maximum speed can a car enter a curve without sliding toward the top edge of the bank turn? Now, अब यहाँ पे देखना है, without slide, question क्या है? Without sliding toward the top edge, ठीक है, right? तो यहाँ पे टेंडेंसी क्या है? टेंडेंसी किस तरफ जाने की होगी? ऊपर की जाने की होगी. Yes or no? If it is the maximum, it is asking maximum velocity. So the tendency of this car should be, tell me, to go up. Yes or no? Tell me, yes or no? मैक्सिमम पूछा है, मिनिमम पूछता तो नीचे होता, मैक्सिमम पूछा है तो ऊपर होगा. सो बताओ, अगर टेंडेंसी मूव करने की ऊपर की ओर है, सो फ्रिक्शन डायरेक्शन कितना होगा? सॉरी, फ्रिक्शन डायरेक्शन किधर होगा? नीचे की ओर. दिस शुड बी डायरेक्शन ऑफ फ्रिक्शन. यस और नो? हाँ या ना? यही कॉन्सेप्ट है. दैट्स द ओनली कॉन्सेप्ट दैट यू हैव टू थिंक, और कोई कॉन्सेप्ट नहीं है. अगर यहाँ पे बोला गया है सर मैक्सिमम स्पीड, सो मैक्सिमम स्पीड कब होगा? जब ये ऊपर की ओर स्लाइड करना चाहेगा. जब ऊपर की ओर स्लाइड करना चाहेगा तो फ्रिक्शन सर नीचे की ओर होना चाहिए, है ना? दैट इज द ओनली कॉन्सेप्ट. अगर यहाँ पे मिनिमम पूछता तो उल्टा होता, तब नीचे की ओर स्लाइड करना चाहेगा, फ्रिक्शन ऊपर की तरफ होगा. ठीक है. सो सर उसके बाद तो इजी है ना सर, राइट? उसके बाद सर आप इजी है, इसका दो कंपोनेंट हो जाएगा, एक ऐसे हो जाएगा इधर, एक नॉर्मल का हो जाएगा, और ये mv² r हो जाएगा, राइट? तो सर n sin theta plus f cos theta is equal to mv² r, ये आ गया. और n cos theta is equal to mg, n cos theta is equal to mg plus f sin theta. ठीक है, थीटा तो यहाँ से पता चल गया है ना? So I can solve these two equation. Yes or no? Tell me yes or no, right? बस दो इक्वेशन सॉल्व करना है ना. इक्वेशन सॉल्व करने में दिक्कत हो सकता है तुम लोगों को, बट करना वही, और कुछ नहीं करना है. जस्ट हैव टू सॉल्व दीस टू इक्वेशंस. ठीक है, इक्वेशन सॉल्व करोगे, डिवाइड करोगे तो ये आ जाएगा. दैट इज द आंसर. ना बहुत जगह पे तुमको डायरेक्टली ये रटवा दिया जाता है, बहुत जगह पे डायरेक्टली रटवा दिया जाता है, बट आई होप ऑल ऑफ यू अंडरस्टूड हाउ टू सॉल्व दिस. हाँ या ना? टेल मी। हाँ या ना? क्लियर हुआ ये चीज? ओके, सो दैट्स इट, राइट, दैट्स इट। ठीक है, तो नेक्स्ट क्लास में हम लोग कंजर्वेशन ऑफ मोमेंटम स्टार्ट करेंगे। तो कंजर्वेशन मोमेंटम के साथ साथ हम लोग स्टार्ट कर लेंगे तुम्हारा कुछ कुछ कोलिजन वाले कॉन्सेप्ट भी। ठीक है, सेंटर ऑफ मास, कोलिजन सब कर लेंगे। ओके, राइट। माय रिक्वेस्ट वुड बी गो थ्रू एनसीईआरटी, एनसीईआरटी की प्रॉब्लम से पता कर लेना बोर्ड्स के लिए। ठीक है।